this one basically should have been 11 through 20 that we're looking at. Okay, number 11. It's where it starts to change gears. It says to find the least common denominator. And they're going to give you two expressions with two different denominators. So the first one we've got x and x over 2. The second one you've got 7x and x minus 5. And as long as they're two different denominators and there's nothing in common, then basically whatever those two numbers are in your denominator, that's going to be your LCD. So it would just be an x minus 2 and x minus 5. Because that's the only thing you have in the denominators. There's nothing to factor out. There's nothing you can do to cancel. So as far as that goes for that part of it, that's all you're going to have is just to tell me what the two things and multiply them together. Okay, for number 12, this one asks you to fill in the blank. We've got negative 5 over 3v plus 5. That equals, there's our blank. And for the denominator, make it 15v plus 25. And a couple options you can do on this one. That basically for this part of it, they're just basically getting you ready for the next part where we're going to add and subtract. So all you have to do for this one is they've kind of given you one denominator and they've said, all right, we've rewritten it here. What do we do? What do we multiply by to go from here to here? And for this one, you went from 3v to 15v. You also went from 5 to 25. So you basically just took that expression and multiplied by 5. Whatever you do on the bottom, you got to do the same thing on the top. So negative 5 times 5, or negative 5 times 5 would be a negative 25. So for that one, that's it. That's all you're doing is they just gave you one denominator, gave you a new one, and you multiplied by some number or some expression, whatever it happens to be, and that's how you get the new denominator. So for 13 here, it asks you to simplify, or in this case, add or subtract. So we've got 8 over x plus 5 and then 6 over x plus 5. And for this one, you already have a common denominator. So there's nothing really to do on the bottom. It just stays x plus 5. And the top part, you're just going to do 8 plus 6 and make it 14. And if you have a common denominator, that's all you have to do is just add or subtract the top numbers. Or you're basically just combining like terms. All right, let's give you one more like that. So let's go 5x plus 3 over 6x, and then plus 3x minus 5 over 6x. Okay, I already have a common denominator, 6x, so nothing to do with that one. Now you're just going to take all the different terms you have on top and just add all those together, so it's 5x plus 3 plus 3x minus 5. So you're really just combining like terms. You've got your 5x plus 3x, that's an 8x. 3 minus 5 is negative 2. And that's over 6x. Now, here's the one thing where once you've done all the addition and subtraction you can do, once you get your final answer, well, once you've got an answer at the end, you've got to look and see if you can simplify that one. 8, 2, and 6, they're all even. So on the top part, what you can do is go one more step. You can actually divide a 2 out of the top. So if you factor a 2 out of the top, you can leave this 2 times 4x minus 1 over 6x. And now that you've got the 2 and the 6 on the outside, you can go back and cancel those, because 2 will go into 2 one time, 2 will go into 6 3 times. So you've got 1 times 4x minus 1, which means it's just 4x minus 1. And a 3 on the bottom. Oh, sorry, thank you, 3x. Okay, so they'll start you in the second half of the test. They start you off with just working through some fractions, just rewriting it, finding the common denominator in some cases, and then they slowly get to the point where finally at number 15, you have different denominators, and then you have to add or subtract. So let's go with 5 over 2 minus 1 over 2c. Okay, and for one, the very first ones, they shouldn't give you too awfully complicated denominators. This one's 2 and this one's 2c. Well, you have a 2 and 2 in common, so it has to definitely be a 2. This one has a c, this one doesn't, so you've got to include everything, so you do have to include the c. So your least common denominator would be 2c. And once you've got your least common denominator, rewrite it for both fractions, and then just figure out, okay, to go from the first fraction from here to here, what do I have to multiply by on the bottom? Well, I have to multiply by c, because that's the only thing that's here. So you'd have to do the same thing on the top, multiply by c. That one we had the 1, and going from here to here, it did not change. So if it doesn't change on the bottom, it doesn't change on the top. Alright, so when you put it all together, it's 5c minus 1, and that's over 2c. Okay, and some odd, some even, so there's no common factors you can divide out of this one. So for that one, that would be your answer. Okay, for 16, same thing. This time you've got different denominators still, but they take up the level of difficulty one more step, because now it's not just a number or a variable. You've got a expression where you're adding and subtracting different parts. But it's still pretty much like that first problem that we had, that you've got to tell me what is the least common denominator. Well, you've got two different denominators. One's x minus 5, the other one's x plus 4, so that is your common denominator. X minus 5 and x plus 4. So we're rewriting both of the fractions. And take your original numerators that you had and go ahead and put those in there. And then you just got to figure out, okay, what did we put extra for the first fraction? What did we multiply the bottom by? Which was x plus 4. And whatever you do to the bottom, got to do the same thing to the top. Same thing on the second fraction. You had x plus 4, we multiplied in an extra x plus 5, or x minus 5. Pretty much. And here again, here's the part where sometimes people do too much too fast. When you put this together, because sometimes people will go back and cancel these out. Remember, you've got to add and subtract everything in the top. So to fight off the cancel bug, I guess, to do canceling too fast, is just write down that's the least common denominator, because once you've got the least common denominator and you've rewritten it, everything else that you do from there on is all in the top. So the work you have to do is you've got to do 2 times x plus 4 plus 3 times x minus 5. And you don't care about the bottom for right now. Everything you're doing from this point forward is working through the tops and just working out the numerator, getting it as far as you can go. And once you've done everything you can do in the numerator, then you pull the denominator back in and see if there's anything you can do with it. Okay, so for this one, do a little distributive property with a 2. So 2 times x is 2x. 2 times 4 is 8. Again, we're not worried about the bottom, so just go ahead and call the LCD. You've got 3 times x for 3x, and 3 times 5 for 15. And again, still not worried about the bottom because you've still got work to do in the top. 2x plus 3x is 5x. 8 minus 15 is negative 7. And once you've done all you can do with the top, you've added, subtracted, you've done all the distributive property, combined like terms, you've done everything you can do, then you bring the denominator back in and see if there's anything you can cancel. Well, 5x minus 7 is way different than everything in the denominator, so if there's nothing you can cancel, then there you go. There's your answer. On the denominator or the numerator? No, you can. If you had an extra x in there somewhere, you could put it here and it would be okay, or you could put it. Yeah, you could. Yeah, it doesn't matter where you put it. It's fine. No, as long as it's in the denominator, it doesn't matter where it is. You could put it. I mean, it look odd. You could put it in the middle. You could do x minus 5 times x plus 4 and have it in the middle, and it's still okay. Okay, 17. Change gears a little bit. It should say something about complex fractions in it. So for this one, it asks you to simplify, but again, it's going to be a complex fraction problem. So it's going to look different than all the other problems that we've done up to this point. So you're going to have something kind of like this. 7/9 minus 1 and 9/4 plus 2. Now, here's where the complex fractions tie in with the other fractions we had before when you were doing addition and subtraction. You still need the least common denominator. So you've got to have that part first. So for the two parts you've got a 9 and a 4. And if it's numbers, if you want to, just to be on the safe side, you can always just do 9 times 4. I mean, you can list them off. You know, if you start listing off all the numbers and the easiest thing to do is list the bigger number. 9, 18, 27, and just list those until you find one that's a multiple of your smaller number. And that's the easiest way to go about it. For this one, eventually you would get 36. So your least common denominator is 36. Yeah, least common denominator, least common multiple, it's kind of interchangeable, yeah. Yeah, that basically you just take, when you do fraction, when you work on least common multiples, when you start doing the fractions, you just replace the multiple with the denominator. But it's the same concept. And the difference with complex fractions is that instead of rewriting everything with that common denominator, now you're going to take every single part that you had here and multiply by that number. And I'm going to jump to another page because this is at the bottom of the page here. So we're going to do 7/9 minus 1. So we're going to do 36 times 7/9 minus 1 times 36. And that was over 36 times 9/4 plus 2 times 36. So take the original fraction you had, this one had 4 different numbers in it. Take every single one of those numbers and multiply by the least common denominator. And when you do that, the fractions should cancel each other out. Because 9 will go into 36 4 times. For this one, 4 will go into 36 9 times. And once you cancel the fractions, now it's just multiplication. 4 times 7 is 28. Minus 1 times 36 is 36. 9 times 9 is 81. 2 times 36 is 72. And just add the numbers on top, or in this case subtract them. 28 minus 36 would be a negative 8. 81 plus 72 would be 153. And if that fraction won't simplify, and this one doesn't, then that would be the final answer for that one. If it does simplify, then just divide it by whatever you can divide into both of them, and then just keep breaking it down. Oh, and then for this one we did 2 times 36, which gave us a 72. Okay, and one more complex fraction with the same directions of just simplify. But this one they throw a variable at you. So we got 7 minus 5 over 2x on the top, 5 over 2x minus 3 on the bottom. And same thing, still got to have the least common denominator. The good news with this problem is you've got the exact same thing in both denominators because you've got 2x in this fraction and 2x in this fraction. So you only have one option for the least common denominator. It's got to be 2x. So from that part, it's still going to be the same thing. We're going to take every single part of that fraction and multiply by 2x. Okay, so again, just take the original fraction that we had, just rewrite it, and then everywhere you've got it rewritten, just put a 2x out beside each of the numbers that's there. And the big thing with this one is your fractions should be gone. You should just have whole numbers. For this one, you've got 2x times 7. Well, that's 14x. For this one, the 2 cancel and the x cancels. So those are all basically just 1s. So this one, you've got 5 times 1. Which would just be 5. For these, the 2x here cancels the 2x here. Again, basically, you're putting a 1 there, so 1 times 5 for 5. And then 3 times 2x would be 6x. Now, and again, here's the temptation you have to fight sometimes. When you do all that good work and you get to the end, sometimes people get tempted and they'll see those 5s and they want to go back and get rid of those 5s and cancel them out. But remember, you have to think about there's a parentheses around this, and there's a parentheses around this. But anytime you've got that plus or minus sign in between those two numbers, they're connected together. You've got to have the exact same thing to be able to cancel that one. So this one was close because these were 5s, but that's a 14 and that's a 6. So because those two numbers are different, there's nothing you can do with that one. And that would be the answer that you're looking for. And for that part, you wouldn't have to have the parentheses because there was nothing you could do with those parentheses. Okay, and then the last two questions, and again, there's only, all that work we did in Chapter 6, there's only 2 questions on the test that we have to work about. So for everybody that was sweating bullets over 7.6, there's 2 questions on the test. It just says solve. We have 4/3 W minus 5 over 2 equals negative 1/4 W plus 5. Okay. Whether you're adding, subtracting, complex fractions, anything that's got some addition or subtraction involved with it, the one thing you have to do every single time is you've got to find the least common denominator. So any part that's got addition or subtraction mixed in with it, you're pretty much doing that. The only time you don't worry about the least common denominator is when you're doing multiplication or division, which were basically the same things there, other than just that one little step. So for this one, you've got 3 numbers. You've got 2, 3, and 4. And again, if you want the fastest way there, just list the multiples of 4 and see if both of the smaller numbers will go into it. 2 will go into 8, but 3 won't. So go to the next number, multiple of 4. 2 will go into 12, 3 goes into 12. Since everything will go into 12, that's our least common denominator. Okay, so every number that we have, again, you could rewrite all the fractions with denominator 12, but the easier thing to do was to take every single number here. I'm going to start on the left because it might take a little bit of room, and multiply every single number by 12. Okay, so original problem in blue, least common multiple or least common denominator was 12. So we're going to take every single thing and multiply it by 12. And that should get rid of all the fractions so that you've only got whole numbers left to work with, and the whole numbers are always easier to work with than the fractions. Okay, so for this one, 3 will go into 12 4 times. 4 times 4 is 16W. For the next one, 2 will go into 12 6 times. 5 times 6 is 30. For the next one, 4 will go into 12 3 times. So you got negative 1 times 3, so that's negative 3W. And the last one was 2 whole numbers, so it's just 5 times 12, so that would make it 60. So once you've got the least common denominator, multiply through to get rid of all the fractions. That's the way it's whole numbers, and everybody would much rather work with the whole numbers than you would with the decimals and the fractions. So now we've got a problem that's hopefully a little bit easier to work through. Because once you're here, we've got the negative 3W, so let's get rid of that one. Let's add 3W to both sides. So that would be 19W minus 30 equal to 60. And from there, only one other thing to do. We're going to add 30 to both sides. So we're left with 19W equal to 90. And then just divide those two to get 90 divided by 19. 19's prime, so there's nothing you can divide into 19. So unless 19 goes into 90, which it doesn't, that's your answer. Again, you don't have to make it into fractions. You don't have to mixed number. You don't have to make it into a decimal. As long as it's a fraction and either improper or proper form, as long as it's simplified down, that's all you have to put. And the good thing about this question is it did not say to check your answers, check your solutions, name the restrictions, all this stuff. So this one, it's good. Just, okay, give me an answer. We're not going to make you check it. Because the last time we said if it said the thing about having no solution as a possibility, you had to go back and check it. This one, it just said to solve it. It didn't say to go through all the parts of it there. The last one, however, can't let you get away with that one, right? Number 20 says to solve it, and if there's more than one solution, separate with commas. And if there is no solution, click no solution. And when they give you all that part in the directions, they're saying, all right, when you get this one, you have got to check your answers. Or what we found out last time was a quick way to do this was state the restrictions in the beginning and then see if the answer you get is one of those restrictions. That seemed to be the easier way to kind of look at it last time. So we'll do that the same way here when we go through this one. Okay. Let's go with 7 over x squared minus 8x plus 15 equals 1 over x minus 3 plus 2 over x minus 5. Okay, so for this one, it starts off with x squared. So the very first thing you need to do with this one is you've got to factor this out as much as possible. And they tell you to factor just the denominators. I'll go ahead and say just factor everything as much as possible. Numerators included because sometimes you get a little nice surprise with some of these. This one you don't, but we'll go ahead and do that. So for this one, you're going to find the factors of positive 15 that equal negative 8. Hint, hint. Could it be 3 and 5? So the good news on this one is when they break this problem down, they've already given you the answers right here. So for this one, really, it's 7 over x minus 3 and x minus 5. So that you've got x minus 3 and x minus 5 in both the denominators. So your least common denominator has to be x minus 3 and x minus 5. And for the solving, we're going to do the same thing as the last one. You're going to take all the terms there, multiply by that least common denominator. And all the fractions should be gone, leaving you with just whole numbers. Okay, so taking the original expression, or equation, multiplying everything by the least common denominator, and again, everything should cancel out fraction-wise and leave you with just whole numbers, because that x minus 3 cancels that x minus 3, That x minus 5 will cancel that x minus 5. On the left-hand side, leaves you with just a 7 all by itself. Because again, technically, when you cancel these out, you get 1s. So you got 1 times 7 for 7. On the right-hand side, that x minus 3 cancels that one. And that will leave you with x minus 5 times 1, which, again, it's multiplied by 1, so it doesn't do anything. On the last part of it, the x minus 5s cancels and leaves you with a 2 times x minus 3. Okay, so multiplying by 1 doesn't change anything. Multiplying by 2 is just distributive property. And this is right up against the bottom of the page, so let me go up, jump to the next page here. X minus 5 plus 2x minus 6, was that right? 7 equals. Okay. And one small thing. Go ahead and put a 1 in front of the x, because it is 1x that's there by itself, and then you can combine like terms. You can do 1x plus 2x to make that 3x. You've got the negative 5 minus 6, that would make it a negative 11. And then 7 equal to that. So once you've taken everything on the right hand side, combine like terms to get it to here, you're going to add 11. And then divide by 3. Now, the one thing we didn't do, that I said we were going to do, that we forgot, is that way back in the beginning, we had to exclude whatever that least common denominator was equal to 0, and that was x minus 3 and x minus 5. So the easier way of, we said you could go back and plug this number back in and check it. The easier way to do it instead of doing it that way is whatever the least common denominator was, you had to exclude that equal to 0. So we had to exclude x equals 3 and x equals 5. X equals 6 was good. So that answer stands, and that's all we needed. If we had gotten, solved this out, if this had been 15 over 3, and we'd gotten that the x was going to equal 5, well, if 5 is an excluded values, we'd have had to chunked it, and then we'd have said this thing would have been no solution. So that is a possibility that may pop up on those. So whenever you get the excluded values, which is easier than going back and plugging it back into the equation and working it out, just list your excluded values. If it happens to be that your answer is one of those excluded values, get rid of it and then tell me what answer you've got left over. But for this one, x equals 6 was good because it didn't fit in the list there.